The standard C++ library provides a number of functions for working with C strings. These are different and distinct from the C++ STL string class. C strings are simple, efficient, and flexible, and are often used where the complexity and power of an object-oriented string class is not necessary. A C string is simply an array of characters terminated with a null value. Here I have a working copy of working.cpp from chapter 9 of the exercise files. And I'm going to just come in here and declare an array of characters. And this array of characters is terminated with a 0 value. And now I can use puts, and I can simply print that value. And when I build and run, you see it displays the word string. And so this array of characters, it has 6 character values followed by a null value or a 0. And that is exactly the same as if I were to do this. And I'll build and run that, and you see we get exactly the same result. And this string is exactly the same as if I were to list out the separate characters string and a 0 value. So this, within the quotes here, is a C string. It's an array of characters terminated with a null value. And this initialization here, this equal sign, is actually a copy constructor. And so it's copying this literal array of characters into this array of characters variable. Now, if instead I do this, I have something subtly different. What I have here is a character string pointer, which is being assigned to the address of this literal array of characters. And so when I build and run here, I get the same result, but I'm not actually copying an entire array. In this case, I'm simply creating a pointer. Now, it's important to note in this case, if I take out this const here, so I'm going to build and run here, and you see I get a warning. Many compilers will warn you or even refuse to convert from the string literal to a character pointer without the const. So now that it's a const character pointer, because in this context, it means that what's being pointed at is a constant. Okay, so this is how C strings work. Now we're going to go ahead and we're going to take a look at the string functions in the standard library. And so to do that, I'm going to delete this working copy. I'm going to run clean. And I'm going to take this string.cpp and make a working copy of that. And we're going to take a look at this. So up at the top here, we declare some variables. I have a constant for a maximum size of a buffer of 128. And we have a couple of constant strings, and these are the pointer variety. So these are constant strings that cannot be changed. And I have a couple of buffers, which are the size of maxbuf, 128 bytes. And I have an integer and a C and a character pointer. So the first thing I'm going to do here is I'm going to go ahead and I'm going to comment out a bunch of this. This will generate some warnings, and that's okay. We're going to live with those warnings for a while. And now when I build and run, we're going to exercise this stir copy part. So there's our warnings, unused variables, and that's fine. So I'm using this function stir copy, and this copies from one string to another. So the first parameter is the destination, the second parameter is the source, and the third parameter is the maximum buffer size. There's another version of this called stir copy without the n, and you should really never use that version because it doesn't check the buffer size, and so it's really not safe. And again, keep in mind that many of these functions may issue a warning in Microsoft C++ and some other environments. Microsoft and some other environments provide their own versions of these functions, often claiming that they're safer. Feel free to use those other versions if you prefer, just understand that they're not standard and may not be available on other systems. So this is stir copy. It's very simple. It copies one string to another. So in this case, our S1 is this pointer to our literal strings, and SD1 and SD2, these are our buffers. And so we're copying both of those and we're printing them out with printf. All right, now let's take a look at strncat. Strncat is for concatenating strings. I'm going to go ahead and build and run this. And you see here SD1 is string 1 dash string 2. And so what I've done here is I have SD1, you see from above it has string 1 in it, and I'm concatenating a literal string with a space and a dash, and then I'm concatenating another string from string 2. So it says string 1 space dash string 2. That's our result. Strncat, the first parameter, is the destination, the second parameter is the source, and the third parameter is the maximum size. And so in this case, you see for our maximum size, I'm subtracting out what the value was before so that I know that I'm not overflowing the buffer. And I did the same thing in the second strncat, concatenation. For taking the length of a string, we have strlen. And it just has two parameters, the string to take the length of and the maximum length that you're going to count. How this works is it actually goes through the string and it looks at every character sequentially looking for that null value. And so if it doesn't find it, you could have a buffer overrun. And so that's why it's important to use the safe version of this with the n. There's another version, strlen, and I've been known to use that on occasion. Sometimes I either forget or very, very positive that I have a null terminated string that I'm working with, but it's really always safer to use the strlen version. For comparing strings, we have strcmp, and this compares the values of two strings. So you have string 1 and string 2, and the result is either a negative value or a 0 or a positive value. So when I build and run here, so I'm comparing string 1 versus string 2, and I get a value of -5. And so that's telling me that string 1 is in collation order less than string 2. And then comparing SD2 to S2, I see that they're exactly the same because my value is 0 and I'm getting this double equals here because I'm testing that condition right here. With strchr, strchr, we can find a character in a string. So we're looking for the character n in the string SD1. And so when I build and run, CP is our result. strchr returns either the position of the first matching character or a null. And so it says the first n in SD1 is at position 4. There's another version of this, strrchar, which searches from the right-hand side, and it'll find the last position. And so, in this case, the last n in SD1 is at position 17. And finally, we have strstr. This is for finding a string within a string. And we're going to look for SD1 within S2. And I'll build and run. And it found it at position 13. And again, it returns the position of the first match or a 0 if it's not found. So these are some of the more common string functions that you'll find in the standard C++ library. Even if you're using C++, you should never be afraid to use C strings. There are times when they're necessary, and there are times when they're just smaller and faster than C++ STL strings. These functions are a great resource for working with C strings.